Construction of bridge foundations in marine environments is one of the most technically demanding operations in civil engineering, requiring precise integration of geotechnical investigation, hydraulic control, and structural construction. The process begins with detailed offshore site investigation. Cone penetration testing is performed to measure cone resistance and sleeve friction, allowing engineers to evaluate soil stratification, relative density, and shear strength parameters. To complement point-based CPT data, seismic reflection surveys are conducted across the entire alignment, generating a continuous subsurface profile and accurately identifying bedrock depth variations. These datasets collectively establish the allowable bearing strata and foundation design parameters. Once the founding levels are confirmed, marine construction equipment is mobilized to the site. Floating barges equipped with cranes and vibratory hammer systems are positioned using GPS-based precision control. Interlocking steel sheet piles are installed sequentially, forming a cofferdam enclosure around the pier location. Vibratory driving is carefully controlled by adjusting hammer frequency and amplitude to optimize penetration efficiency while preventing pile deformation. As installation progresses, the sheet piles are embedded to the required depth to ensure both seepage control and lateral stability. After the cofferdam wall is completed, structural stability is enhanced through installation of wallers, internal bracing frames, and pre-stressed tie rod systems designed to resist hydrostatic and lateral earth pressures. Instrumentation continuously monitors deformation, ensuring that structural limits remain within design tolerances. Controlled dewatering operations then commence. High-capacity pumps gradually reduce the internal water level, maintaining equilibrium to avoid excessive pressure differentials. Once dewatered, excavation proceeds within the enclosure until the founding stratum or bedrock surface is exposed. Where high structural loads are anticipated, large-diameter steel pipe piles are installed through vibro driving, followed by rotary drilling to achieve full penetration into competent rock. Reinforcement cages are lowered into position and structural concrete is placed to complete the deep foundation system. To eliminate base seepage and provide uplift resistance, an underwater tremie concrete seal slab is constructed. Tremie pipes extend to the base of excavation, and anti-washout concrete is placed using bottom-up placement methodology. The dense concrete displaces water upward without segregation, forming a continuous impermeable seal that stabilizes the foundation base. Following seal slab completion, reinforcement for the pier footing is assembled, and mass concrete placement is carried out in stages. Temperature monitoring systems track hydration heat to prevent thermal cracking, ensuring long-term durability. After curing reaches the specified strength, the cofferdam bracing is dismantled, and the enclosure is removed, revealing the completed bridge pier foundation ready for superstructure construction. Through careful geotechnical characterization, controlled hydraulic management, and precision structural execution, offshore bridge foundations achieve the stability required to safely transfer massive structural loads to competent bearing strata, ensuring long-term performance in highly demanding marine environments. In offshore bridge engineering, foundation construction is not merely a structural operation. It is a coordinated integration of geotechnical science, hydraulic engineering, and precision construction management. Every investigation reading, every pile installed, and every cubic meter of concrete placed contributes directly to the long-term stability and safety of the entire bridge system. When executed with rigorous engineering control and monitoring, these offshore foundation systems are capable of sustaining extreme environmental loads for decades, forming the critical base upon which modern transportation infrastructure reliably stands.